right now, somewhere above you, there is light that has been traveling for over 13 billion years just to reach your eyes tonight. You don't have to do anything with that thought. Just let it sit there for a moment, quiet and enormous, the way a held breath sits in a warm room. Tonight, we're going to slowly follow that light backward, all the way to the very beginning of everything. Not with charts, not with equations, just with a slow, gentle walk through the story of how our universe began. You can close your eyes whenever you like. I'll keep talking. You don't have to remember any of it. There's no need to hold on tightly to any of this. Some of what we talk about tonight will be strange, almost impossible to picture. And that's all right. You're allowed to let the words drift past you like a slow river, catching a phrase here, an image there, letting the rest simply flow on by. This isn't a lecture. It's more like a long, slow bedtime story. One that happens to be true. Let's start small, the way the universe itself did. Picture a point. Not a point like a period on a page, but something stranger. A point with no space around it, because space itself hadn't been made yet. No up, no down, no left, no right, no time passing, because there was no before for time to move through. It's a strange thing to imagine, and you don't need to fully grasp it tonight. Even the scientists who study this for a living, some ideas are meant to be approached slowly, over and over, a little more each time. Tonight is just one of those times. Inside that point, everything would ever become anything was folded together. Every star that has ever burned, every planet that has ever turned slowly in the dark, every ocean, every grain of sand, every breath you've ever taken, all of it compressed into something smaller than you can picture, hotter than any number can really describe. And then it began to expand, not like an explosion in the way we usually think of explosions, with fire bursting outward into an empty room. There was no room to burst into. Space itself was stretching, expanding from within, carrying everything along with it. It's a soft but strange idea, one you can just let wash over you rather than solve. The universe wasn't expanding into something. It was simply becoming bigger, everywhere, all at once. Take a slow breath with me here, because this next part moves fast, faster than almost anything we'll talk about tonight. 4. and then it will slow right back down again. In that very first sliver of a second, so small a sliver that most of us will never truly hold it in our minds, something extraordinary happened. Physicists call it inflation. Not the kind of inflation you might think of with prices slowly creeping upward over the years, but something far stranger and far quicker. In a fraction of a second, smaller than anything we can properly compare to daily life, the universe is thought to have expanded by an almost unthinkable amount. If you try to picture it as something ordinary, like a single grain of sand suddenly swelling to the size of an entire galaxy, you still wouldn't quite capture how fast or how vast that moment truly was. And then, just as suddenly as it began, that rapid stretching slowed. The universe kept expanding after that, of course, but gently now, calmly. The way a held breath is finally let out slow and even. Whatever caused that first burst of inflation is still one of the softest, most open questions in all of this. Scientists have ideas, careful and thoughtful ones, built on decades of observation. But there's still room for wonder here. Still room for the universe to keep a few of its secrets a little longer. You don't need to solve that mystery tonight. You can just let it rest there. One gentle unknown among many, while we keep walking forward through time. After that first burst of expansion, the universe was left in a state that's hard to picture in ordinary terms. Unimaginably hot, unimaginably dense, a blazing, responsible for seething soup of energy and the smallest building blocks that would one day become everything else. Physicists sometimes call this the primordial plasma, though the word plasma might make you think of something orderly, something you could observe calmly from a safe distance. This was closer to pure, chaotic fire, if fire could exist without anything solid yet to burn. In that fire, the fundamental forces of nature, the ones that govern how particles push and pull on each other, were still tangled together as one. You can think of it a little like a single low, warm hum before it slowly split into separate notes. As the universe expanded and cooled ever so slightly, these forces began to separate from one another, one by one, like instruments slowly stepping out of a single sustained chord, until each one could be heard on its own. First, gravity split away, the earliest of the forces, to become distinct. still governing how everything with mass gently pulls on everything else. Even now, even in this quiet room around you. Then, as the universe cooled further, the strong force separated too, the one that would eventually hold the centers of atoms together. Later still, the force that once combined electromagnetism and what's called the weak force split apart into the two we know. Today, the invisible pull that keeps a magnet stuck to a refrigerator, and the quieter, stranger force involved in how certain particles slowly transform into others deep inside the hearts of stars. None of this needs to make perfect sense tonight. What matters, if anything matters right now, beyond the sound of my voice and the weight of your own breathing, is simply the picture. A universe cooling, forces slowly settling into their separate roles. Order ever so gently, beginning to emerge from chaos. As the universe expanded, it also cooled. This is one of the gentle rules that has stayed true ever since. When something spreads out, it cools down. Your tea does this on the counter. A field does this as the sun sets. The universe did this too, just on a scale that swallows imagination whole. For that first tiny stretch of time, the universe was too hot for anything solid to exist at all. Even particles as we understand them today, the ones you might vaguely remember from a school science class, protons, neutrons, electrons hadn't fully formed yet. Instead, there was a churning sea of even smaller particles, called quarks and gluons, moving freely, never quite settling down, never staying still long enough to bind into anything larger. Scientists call this the quark-gluon plasma, and, if you like, you can simply picture it as a kind of restless, glowing fog, far too hot and far too energetic for anything to hold together. It might help, too, to know that scientists haven't simply to imagine this stage from a distance. In laboratories here on Earth, using enormous machines that gently accelerate particles to tremendous speeds before letting them collide. Researchers have managed to recreate tiny, fleeting patches of this same quark, gluon plasma, just for the briefest instant, hotter even than the core of the sun. It lasts only a fraction of a second before cooling and settling back down into ordinary particles. Far too short a time for anything solid to ever form from it. But in that brief flicker, scientists catch a small, careful glimpse of conditions that once filled the entire universe everywhere, all at once, in that very first heartbeat of existence. There's something quietly moving in that, if you let it settle over you, that the same conditions which once filled absolutely everything, every corner of a universe that would eventually become galaxies and oceans, and this very room can now be gently, carefully recreated for just an instant, deep underground, by careful, patient hands, simply so we can better understand where we came from. Slowly, as the universe continued to expand and cool, that restless fog began to calm. Quarks started finding each other, binding together in small groups, forming the first protons and the first neutrons. This didn't happen all at once, the way flipping a switch turns on a light. It happened gradually, unevenly, in a slow settling that took only a fraction of a second by the clock, but which represented an enormous shift in what the universe was capable of becoming. By the time the universe was about 1 second old, and by now, 1 second really does mean 1 second, not some impossibly small sliver of it. Something else had happened too. A great imbalance had been set in the universe. One that we still benefit from today, even if we rarely think about it. For every particle of matter, there should have been, in theory, an equal and opposite particle of what's called antimatter. And when matter and antimatter meet, they annihilate each other, vanishing in a burst of pure energy. If the universe had been perfectly balanced between matter and antimatter, it's thought that almost everything would have canceled itself out, leaving behind a vast, empty stretch of energy and very little else. No stars, no planets, no quiet room for you to be resting in right now. But for reasons scientists are still gently trying to understand, matter had a very slight edge, just a tiny fraction more of it than antimatter. For every billion pairs that annihilated each other, one particle of matter was left behind, unmatched, drifting alone. That tiny imbalance, so small it's almost hard to call it an imbalance at all, is the reason anything exists today. Everything you can see, everything you can touch, this room, your own body, breathing slowly in the dark, all of it is made from that leftover fraction, the part of the universe that had nothing left to cancel it out. It's a strange thing to think about, how something as vast and complicated as everything can trace itself back to such a small, quiet, asymmetry. But maybe that's fitting in its own way. Big things often do start from very small differences. Even now, scientists gently study this same question, trying to understand exactly why that small imbalance existed in the first place. Why matter got the slight advantage instead of antimatter, or instead of neither existing much at all. It's one of those quiet threads in this story that hasn't been fully tied off yet. One more soft, open question resting patiently among all the others. Experiments continue carefully, patiently, comparing matter and antimatter particles in delicate detail, searching for any small clue that might explain that ancient, fortunate imbalance. So far, the full answer still waits for somewhere just out of reach, content to be searched for a little longer. You don't need to hold on to that question tonight either. It's simply nice to know that it's being asked gently, carefully, by people who've devoted their lives to sitting patiently with exactly this kind of vast, quiet uncertainty. For the next few minutes, and I do mean minutes now, actual minutes ticking by the way they do on any ordinary clock, the universe entered a period scientists call primordial nucleosynthesis. It's a long word, but the idea behind it is gentle enough. The protons and neutrons that had formed earlier began finding each other, joining together into the very first atomic nuclei. This process didn't last long, not by the standards of everything that came before or after. It began just a few seconds after the very beginning, and it was essentially finished by the time the universe was about 20 minutes old. 20 minutes. It's strange to think that something so foundational, for something that determined the basic chemical ingredients for the next 14 billion years, happened in about the same time it takes to boil a pot of water and let it simmer. During those 20 minutes, protons and neutrons combined mostly into hydrogen, the simplest possible element, just a single proton at its core. Some of them went further, combining into helium, the second simplest element, with 2 protons and 2 neutrons bound together. A much smaller amount combined into lithium, a light, gentle element you might recognize from certain batteries today, though of course batteries were unimaginably far in the future at this point. And then, almost as quickly as it began, this process stopped. The universe had cooled and thinned out enough that protons and neutrons could no longer easily find each other and combine. Whatever hadn't already joined together stayed as it was, drifting quietly through space as loose protons, on their way to becoming hydrogen atoms, eventually. Once conditions were right, that's it. That was the entire chemical makeup of the young universe. In those first 20 minutes or so, no oxygen yet, no carbon, no iron, none of the elements that would one day make up rivers, or bones, or the roof over your head, or the blanket you might be resting under right now. Just the simplest ingredients, hydrogen and helium mostly, with the faintest trace of lithium, waiting patiently for hundreds of millions of years to slowly become something more. For a long stretch after that, the universe was dark. Not empty, but dark in a particular way, full of particles and energy, but too hot and too dense for light to travel freely. Light existed, but it kept getting trapped. 4. Scattering endlessly off the charged particles filling space. 4. The way fog scatters a car's headlights, so you can't see very far ahead. You can picture it, if it helps, as being inside a thick cloud. 4. One so dense that even though there's plenty of light trying to move through it, none of it can travel more than a short distance before bouncing off something else and changing direction. A photon of light born in this era might travel a tiny distance, only to strike a stray electron and scatter off in some new direction, over and over again, never managing a clear, straight path. This lasted for what would have felt, if anyone had been there to feel it, like a very long time. Though, of course, no one was there yet. There were no eyes, no ears, no one to notice the dark at all. This period is sometimes softly called the photon epoch, simply because photons of light were, in a sense, the dominant character of the story, even though none of that light could travel very far or very freely. The universe hummed instead with radiation, an intense and pervasive glow that filled every corner of existence, trapped by its own density, unable to break free. And through all of this, the universe kept expanding, kept cooling, slowly, patiently, the way TF on a counter overnight slowly reaches room temperature, no matter how hot it once was. Then, around 380,000 years after the beginning, which sounds long, but is really just a blink compared to what came after, the universe cooled enough for something quiet and important to happen. Electrons finally slowed down enough to be captured by those atomic nuclei, forming complete, stable atoms for the first time. Hydrogen atoms, mostly. Helium atoms, too. Whole, complete. No longer just loose particles scattered through the plasma. Scientists call this moment recombination, though it's a slightly funny name, since the electrons and nuclei weren't really combining again after some earlier separation. Not exactly. It's more accurate to think of it simply as the moment atoms first became whole. And once that happened, light was set free. It stopped scattering. It stopped bouncing endlessly off charged particles. For the first time, light could simply travel in a straight line for as far as it liked, with nothing left in its way to stop it. That light is still traveling. We can still see it today, stretched out and cooled by billions of years of expansion, arriving now as a faint glow scientists call the cosmic microwave background. It reaches every part of the sky, in every direction you could possibly look, if you had the right instrument to see it. It's sometimes called the afterglow of the Big Bang, and in a quiet way, it still is exactly that, an echo, a very old, very soft echo, still humming faintly across the universe, still reaching us tonight, still reaching this very room, passing gently through the walls and the windows and settling for just a moment around you. If you had a very sensitive receiver right now, tuned just right, you could pick up a faint, steady static, the tail end of that same ancient light, stretched so far by billions of years of cosmic expansion that it no longer looks like light at all, at least not the kind our eyes can see. It's cooled down into microwaves instead, gentle and low, a background hum sitting quietly behind everything else in the universe. For some very old television sets, tuned to an empty channel, would pick up a tiny fraction of that static without anyone ever realizing what they were hearing. A little bit of the birth of everything, crackling quietly in the corner of a living room. After that release of light, the universe entered a long, quiet stretch. Scientists sometimes call it the cosmic dark ages, though it's not dark in a frightening way, just dim, just patient. There were no stars yet to light up the sky, no galaxies swirling slowly in the distance, just hydrogen and helium, drifting quietly through an expanding universe, and that faint, freed light from recombination, spreading out further and further, growing fainter and cooler with every passing year. Matter drifted slowly through space, pulled gently by gravity, clumping together here and there in places that were ever so slightly denser than their surroundings. These weren't dramatic differences, not at first. Just the faintest unevenness left over from that first burst of inflation. Tiny ripples in the density of matter, so subtle that if you'd been able to look at the universe as a whole back, then it might have seemed almost perfectly smooth. But almost isn't quite the same as completely. And gravity, patient as always, noticed even the smallest differences. Over hundreds of millions of years, those slow gatherings grew. Clouds of hydrogen and helium pulled tighter and tighter together under their own gravity, growing denser, growing warmer at their cores. It's a bit like how a gentle breeze can slowly pile up leaves against a fence, not through any sudden force, but simply through the slow, steady accumulation of small movements over a long stretch of time. And eventually, in the heart of one of those clouds, the pressure and heat became so great that hydrogen atoms began fusing into helium, releasing enormous amounts of energy in the process. That was the birth of the first stars. You can picture it, if you like, as tiny sparks lighting up one by one across a vast, dark room. Each one a small fire in a home that had never known any light of its own before. Scientists sometimes call these earliest stars population Earth-eye stars, an oddly technical name for something so significant. These stars were unlike almost anything that exists today. Made purely of hydrogen and helium, with none of the heavier elements that later stars, including our own sun, would eventually contain. They burn differently. Many of them are thought to have been enormous, some many times more massive than our sun, burning through their fuel quickly and fiercely, living short, brilliant lives compared to the slow, steady burn of stars like ours. We haven't directly observed one of these very first stars yet, not with complete certainty. They lived and died so long ago, and their light has traveled and stretched for so many billions of years that catching a clear glimpse of them sits right at the edge of what our best telescopes can currently do. But scientists have found what looks like their fingerprints, gentle traces left behind in the chemical makeup of some of the oldest stars. We can observe hints of a universe that hadn't yet been enriched with anything more complex than hydrogen and helium. It's a bit like finding footprints in old, undisturbed snow. You may not see the person who made them, but, with quiet confidence, that they were there. Slowly, more and more of these early stars began to shine. Galaxies began to take shape, loose collections of stars, gas, and dust. Drawn together by gravity into the great, spiraling and swirling shapes we now photograph from Earth. This didn't happen instantly, and it didn't happen neatly. Early galaxies were often smaller, messier, more irregular than the calm, where graceful spirals we're used to seeing in photographs today. Over time, some of them merged together, for gently colliding and combining over spans of millions of years, gradually growing into the larger, more organized structures we recognize now. Our own galaxy, the Milky Way, was one of these slowly forming, slowly turning over billions of years. It's strange, and maybe a little comforting, to think that the galaxy holding our entire solar system, our entire world, our entire lives, was once just one small, messy cloud among countless others. 4. Drifting through the dark ages, patiently gathering itself together. Inside those early stars, something else important was happening. Something that would eventually matter very deeply to you, resting quietly right now. Fusion doesn't stop at helium. Given enough time and enough mass, stars fuse heavier and heavier elements in their cores, layer by layer, the way certain slow, careful crafts build up thin layers over time until something solid and complete takes shape. In the hottest, most massive stars, hydrogen fuses into helium, and helium eventually fuses into carbon. From carbon, given enough pressure and heat, the process continues. Oxygen, neon, silicon, and eventually, elements like iron begin to form. In the very center of the star, layer upon layer, like the rings inside an old, ancient tree. Except each ring here represents a slightly heavier element than the one before it. Iron, though, is where this gentle, ongoing process runs into a limit. Fusing elements up to iron releases energy, which is part of what keeps a star shining. 4. Part of what pushes back against the star's own gravity, trying to collapse it inward. But fusing iron into anything heavier doesn't release energy. It actually requires energy drawing it in rather than giving it out. So, when a massive star's core becomes mostly iron, it suddenly has nothing left to hold itself up. Gravity, which had been patiently waiting this whole time, finally wins. And when the largest of those stars finally ran out of fuel, they didn't fade away quietly. They collapsed, then exploded in what we call a supernova, scattering the elements they'd built across space in a bright, brief burst. For a short time, a single supernova can outshine an entire galaxy of billions of ordinary stars, all that built up energy releasing itself in one enormous, generous burst. And in the extreme heat and pressure of that explosion, even heavier elements are formed, for ones that couldn't have been made through ordinary fusion alone. Elements like gold, like silver, like the calcium sitting quietly in your bones right now. Almost everything around you tonight was made this way. The calcium in your bones, the oxygen you're breathing right now, slow and easy. The iron carried quietly in your blood, the same element that once sat heavy and still in the collapsing core of some long vanished star. All of it, it was forged inside the heart of a star that lived and died long before our solar system ever existed. It's a strange, tender thought to fall asleep to, that you are made, quite literally, from the light of stars that burned out billions of years ago. Even the very heaviest elements, the ones near the far end of the periodic table, gold, platinum, 4 elements you might recognize from a ring resting quietly on a bedside table, are thought to come from an even more extreme event than an ordinary supernova. The collision of two extraordinarily dense, collapsed stars, called neutron stars, spiraling slowly into each other over unimaginable stretches of time before finally merging in one brief, brilliant burst. Scientists only confirmed this fairly recently, catching both the light and the very faint ripples in space itself from one such collision, happening in a distant galaxy billions of years after it actually occurred. In that one brief, violent, beautiful moment, an amount of gold was created that outweighs anything ever mined across the entire history of humankind. It's a gentle, almost dizzying thought that something as small and quiet as a ring or a coin or a single thread of gold carries within it the memory of two impossibly dense stars, spiraling slowly together across billions of years before finally, briefly, merging into light, as more and more stars lived and died across the young universe. Something else was slowly happening in the space between them. All that ultraviolet light pouring out from the hottest, brightest early stars began interacting with the neutral hydrogen gas, still drifting quietly through space. The same hydrogen left over from the very early universe. Slowly, patch by patch, region by region, that starlight began to strip electrons away from hydrogen atoms, once again turning neutral gas back into charged particles, a process scientists gently call reionization. This didn't happen everywhere at once. You can picture it a little like early morning light, slowly spreading across a landscape. Some areas catching the light first, brightening gradually, while other pockets remain in shadow a little longer, until eventually, over hundreds of millions of years, the entire universe had been touched by this slow, reionizing glow. By the time this process finished, the universe had transformed again from the largely neutral, dim expanse of the dark ages into something more like the transparent, star-filled universe we're familiar with today. Galaxies continued to grow throughout all of this, drawing in more gas, forming more stars, occasionally merging gently with their neighbors. Our own Milky Way is thought to have grown partly through countless small mergers like this over billions of years, absorbing smaller galaxies, weaving their stars into its own slowly forming spiral arms. Even now, incredibly slowly, our galaxy continues this process, though on a scale so long that nothing about it will ever be noticeable within a single human lifetime, or 1,000 lifetimes, or many, many more than that. Our own solar system didn't form until much later, around 9 billion years after the Big Bang, which means the universe had already lived through more than half of its current age before our sun ever came into being. A cloud of gas and dust left over from generations of earlier stars, their elements scattered across space by supernova after supernova, slowly began to collapse under its own gravity. Most of it gathered at the center, growing hot and dense, enough to ignite, and that became our sun. The leftover material, spinning slowly around it in a wide, flattened disk, gradually clumped together into planets, moons, asteroids, and comets. Small particles of dust collided gently and stuck together, forming slightly larger clumps. Those clumps collided with others, growing larger still in a slow, patient process that took millions of years to produce anything resembling the planets we know today. Nearby, other small clumps of rock and gas settled into their own quiet orbits too. A small, dry, rust-colored world we'd later call Mars. A thick, cloud-covered world we'd call Venus, so close to the sun that its surface grew hot enough to melt lead. Farther out, enormous worlds made mostly of gas, slowly gathering thick, swirling atmospheres, along with families of their own, moons circling gently around them. Each one settled over millions of years into the quiet, orderly path it still follows tonight, circling the sun the way it has for over 4 billion years, without ever needing to be told to keep going. One of those small clumps of rock, warmed just enough by its distance from the sun, not so close that it would scorch and bake, not so far that it would freeze into permanent ice, cooled slowly over millions of years. Water gathered on its surface, carried perhaps partly by icy comets that collided with it early in its history, partly by processes deep within the young planet itself, and eventually, in ways we still don't fully understand, ways that remain gently, patiently mysterious even now, the first simple forms of life appeared. That, of course, was Earth. Early in its history, not too long after it had formed. Earth is thought to have collided with Eva, another young, roughly Mars-sized world, in a slow, enormous impact that reshaped both of them entirely. Out of the debris scattered by that collision, drawn together again by gravity, our moon slowly formed, settling into a close, steady orbit around our planet, one it has quietly kept ever since. That same moon, hanging outside your window tonight. Whether you can see it right now or not, has been patiently circling Earth for over 4 billion years, gently pulling at the oceans, shaping the rhythm of the tides. A slow, steady, ancient companion. It's worth sitting with just for a moment. How much time separates that first tiny point, Edom? Hotter and smaller than anything we can properly imagine. From this exact moment, right now, with you lying quietly, listening to a voice describe it. Nearly 14 billion years passed. Stars were born and burned out. Galaxies drifted slowly apart. And somewhere in all of that vast stretch of time, on one small planet, circling one ordinary star, life appeared. and eventually became curious enough to wonder where it came from. That curiosity is still here tonight, resting quietly in your chest as you listen. Before we go further into what science has managed to learn, it might help to sit for a moment with just how large this whole story really is, not in a way that needs to feel overwhelming, but in a way that might feel almost soothing. The way looking out at a wide, calm ocean can feel soothing, even though the ocean itself is far too vast to ever fully take in at once. If you tried to walk the distance between the Earth and the Sun at an ordinary, unhurried walking pace, never stopping to rest, it would take you well over 3,000 years. And the Sun, our own quiet, steady star, is just one among roughly 200 billion stars in our galaxy alone. 200 billion. If you tried to count them, one per second, without ever pausing to sleep or eat, it would take you more than 6,000 years just to reach that number, and that's only the stars in our own galaxy, not the countless other galaxies scattered throughout the rest of the universe. Our galaxy, as vast as it feels, is just one among what scientists estimate to be hundreds of billions of other galaxies scattered throughout the observable universe, each one containing its own billions, sometimes trillions, of stars. It's the kind of number that stops meaning very much once you say it out loud. Numbers that large aren't really meant to be understood the way you understand the number of steps to your kitchen or the number of pillows on your bed. They're meant, maybe, to simply be felt the way you might feel the size of the sky without ever counting the stars in it. There's a gentle word scientists use for the very furthest edge of what we can ever hope to see, called the observable universe. It isn't the edge of the universe itself, not necessarily, just the edge of what light has had time to travel to us since the very beginning. Because light moves at a fixed, finite speed, and because the universe is only so old, there's a limit to how far away anything can be and still have its light reach us by now. Beyond that limit, there may be more universe, still more galaxies, more stars, for simply too far away for their light to have arrived yet, even after 14 billion patient years of traveling. It's a soft, almost comforting kind of boundary when you think about it slowly. Not a wall, not an edge in the way a room has edges, just a quiet limit set by time itself, by how long light has had to travel so far. And every single night, as the universe continues to age, that boundary very gently widens, just a little, allowing a little more light from a little further away to finally arrive. Even our closest large neighboring galaxy, a great spiral not unlike our own, sits so far away that its light takes about 2.5 million years to reach us. Which means that if you were able to see it clearly in the night sky, for the light entering your eyes would have left that galaxy long before humans. In anything like our current form existed at all. In a very real sense, looking up at the night sky is always a kind of looking backward, catching glimpses of moments that, from the perspective of wherever that light began, have already long since passed. And yet, for all of that vastness, all of that almost incomprehensible scale, the whole story still comes back gently to small, quiet things. A single point smaller than anything, a tiny imbalance between matter and antimatter, a handful of light elements formed in 20 patient minutes, a single small planet circling a single ordinary star among all those billions. And on that planet, tonight, a single quiet room, and you resting inside it. The universe is unimaginably large, and yet somehow, improbably, it still made room for this. For you, right now, listening, breathing slowly, drifting gently toward sleep. It might be worth pausing here too, gently, to talk about how we actually came to know any of this. Not with hard numbers or complicated formulas, just softly, the way you might explain to a curious child how someone figured something out. For a very long time, people simply assumed the universe was fixed and unchanging. The same yesterday, today, and tomorrow, without any real beginning at all. It's a comfortable thought in its own way. Something so vast, so far beyond us, simply existing forever, without needing an origin story of its own. But early in the last century, a quiet, careful observation began to change that picture. For astronomers noticed that when they looked at distant galaxies through their telescopes, examining the light coming from them very closely, something curious kept happening. The light from those galaxies was slightly stretched, shifted gently toward the red end of the light spectrum in pattern that seemed to depend on how far away each galaxy was. The farther away a galaxy sat, the more its light seemed to be stretched. This gentle stretching of light is called redshift. And it happens for a reason similar to something you may have noticed with sound. Think of an ambulance driving past you. Its siren sounding higher in pitch as it approaches, then noticeably lower as it moves away. That's because sound waves get compressed as their source moves toward you and stretched as it moves away. Light can behave in a similar way, and what astronomers were seeing again and again, in every direction they looked, was that distant galaxies appeared to be moving away from us, and the farther away they were, the faster they seemed to be receding. This observation, made carefully and patiently over many years, led to an idea that seemed almost too large to hold at first. If distant galaxies are moving away from us in every direction, and if the ones farther away are moving away faster, that suggests something remarkable. The universe itself is expanding, not galaxies moving through some fixed, unchanging space, the way cars move along a fixed road, but space itself, gently stretching, carrying galaxies along with it. The same slow stretching we talked about earlier tonight. And if you take that idea and run it backward, gently, like slowly rewinding a very long, very old film, you eventually arrive at a moment when everything must have been much closer together, and further back still, and further back again, until you arrive at that first point we started with tonight. Everything folded into something impossibly small, impossibly hot, impossibly dense. This is, in its simplest form, the reasoning that first led scientists toward the idea of the Big Bang. Not a sudden guess, not a leap of imagination alone, but a slow, careful trail of evidence, one quiet observation leading gently to the next. Later, that faint background light we talked about earlier, the cosmic microwave background, provided another piece of this same puzzle. If the universe really had been unimaginably hot and dense in its early history, then there should be a faint, leftover glow filling the entire sky, cooled now by billions of years of expansion. And when scientists finally built instruments sensitive enough to detect it, quite by accident at first, they found exactly that. A faint, steady hum of radiation coming from every direction in the sky, at almost exactly the temperature predicted by the theory. It's a rare and beautiful thing in science when a quiet prediction made on paper turns out to match something real, something you can actually detect and measure in the world. It doesn't happen every time, but when it does, it feels a little like a very long, very patient conversation finally receiving its answer. Since then, scientists have gathered even more evidence, layer upon layer, much like the layers built up inside those early stars. The relative amounts of hydrogen and helium we observe throughout the universe today match closely with what the theory predicts should have formed in those first 20 minutes. Those after the beginning. The large-scale structure of the universe, the way galaxies cluster together in vast, web-like patterns, with great empty voids between them, matches the patterns we'd expect to grow from those tiny ripples left over from inflation. Piece by piece, observation by observation, a coherent picture has slowly come together. None of this means every question has been answered. Far from it. There are still deep, gentle mysteries woven through this story, ones that scientists continue to explore patiently, decade after decade. For one, there's the question of what's sometimes called dark matter. When astronomers study how galaxies rotate, how stars move within them, they notice something curious. Galaxies seem to be held together by far more gravity than the visible matter within them. The stars, the gas, the dust could possibly account for on its own. It's as if there's some other kind of matter present, invisible to our telescopes, giving off no light of its own, but still exerting a gentle gravitational pull. We can't see dark matter directly. We can only infer it's there by watching its gentle effects on the things we can see. The way you might notice a breeze moving through a room by watching how the curtains sway, without ever seeing the air itself. Scientists have proposed various ideas about what dark matter might actually be. But as of tonight, it remains one of the universe's quieter, more persistent secrets. Then there's dark energy, for a different mystery altogether, discovered a little more recently. For a long time, scientists assumed that the universe's expansion, set in motion by the Big Bang, should be gradually slowing down over time, the way a ball thrown into the air slows as gravity pulls it back. Gravity, after all, pulls everything together. It seemed only natural that it would eventually slow the universe's expansion too. But when astronomers carefully studied the light from from very distant supernovae, ones far enough away that their light had been traveling for billions of years. They found something unexpected. The universe's expansion isn't slowing down, it's speeding up. Some mysterious force or property of space itself seems to be gently pushing everything apart faster and faster as time goes on. Scientists call this dark energy, though the name is really just a placeholder for something not yet fully understood. It's a bit like giving a name to a stranger you've noticed influencing events from a distance, without ever actually meeting them face to face. Whatever dark energy turns out to be, it appears to make up a significant portion of everything in the universe, more even than ordinary matter and dark matter combined. If you were to gently divide up everything in the universe by what it's actually made of, ordinary matter, the kind that makes up stars, planets, oceans, and you, resting quietly right now, would only account for a small slice of the whole. Something closer to a quarter of everything would be that mysterious dark matter we talked about a moment ago. And the largest share of all, well over half, would be this quiet, persistent dark energy patiently pushing everything apart. In a very real sense, most of the universe is still, even now, gently unnamed. There's one more quiet character worth mentioning in this story, tucked away in the center of nearly every galaxy, including our own. A supermassive black hole, unimaginably dense, with gravity so strong that nothing, not even light, can escape once it crosses a certain boundary. It sounds like it should be frightening, and in a way, black holes have earned a dramatic reputation over the years. But out here, in the quiet of a bedroom at night, it might help to think of them a little differently. Not as something violent or hungry, but simply as an extreme. A place where the ordinary rules bend and curve in ways that are still being carefully studied. Our own galaxy holds one of these quietly at its center, a patient, invisible anchor around which the rest of the Milky Way slowly turns. The way a whirlpool turns gently around its own still center. It doesn't reach out. It doesn't pull in anything nearby. Our sun and our small planet, along with it, orbit peacefully around the galaxy's center, completing one full loop roughly every 230 million years. An orbit so slow and so vast that in all of human history, We've barely moved along a tiny fraction of that single patient circle. It can feel strange, even a little unsettling, to realize how much of the universe remains mysterious even after everything scientists have carefully pieced together. But there's a kind of comfort in that too, if you let there be. The universe still has secrets. It still has room for wonder, for careful, patient curiosity, the same curiosity that first looked up at a shifting light in the night sky and quietly began to ask, why? There's another gentle mystery worth mentioning tonight, one that sits right at the very edge of everything we've talked about so far. What, if anything, came before the Big Bang? What caused that first, unimaginably small point to begin expanding in the first place? It's the kind of question that can feel almost dizzying to sit with for too long. The way staring up at a truly vast night sky can sometimes make you feel pleasantly small. Some scientists have proposed that the concept of before might not even apply here. That time itself began at that first moment, meaning there was no earlier point for anything to have happened in. It's a bit like asking what's north of the North Pole. The question feels natural to ask, but the very framework it's built on may not quite hold up at that particular point. Others have gently proposed different ideas, that our universe might be one of many, part of some larger, unimaginably vast structure, sometimes called a multiverse, with new universes occasionally beginning in ways we don't yet understand, or that the universe might not have had a true beginning at all, but instead moves through long, slow cycles, expanding and eventually contracting, only to begin expanding again, over and over, across a time scale so long that even 14 billion years would be just one small breath within it. None of these ideas have been confirmed. They remain, for now, gentle possibilities. Careful thought experiments built on the edges of what we can currently observe and measure. And that's all right. Not every question needs an answer tonight, or this year, or even within our lifetimes. Some mysteries are simply meant to be carried gently, turned over slowly in quiet moments, like this one, without any pressure to resolve them completely. Let's come back for a while to smaller things, gentler things, things a little closer to home. After our solar system formed, roughly 9 billion years after the universe began, Earth spent its earliest years as a very different place than the one we know now. Hot, mostly molten, without the calm blue oceans or the greens and browns of solid, weathered land. Over millions of years, it slowly cooled. A solid crust began to form. Water, arriving perhaps through collisions with icy comets, perhaps released slowly from within the planet itself, began to gather, first as vapor, then eventually, as the planet cooled further, as liquid, filling in the low places, forming the very first oceans. It's worth pausing on that, gently, for a moment. The same water, sitting quietly in a glass beside your bed tonight, if you have one there, may be made from molecules that have existed in one form or another since nearly the very beginning of our solar system. Water doesn't really disappear. It moves, it changes form, evaporating into clouds, falling as rain, flowing into rivers, settling into oceans. But the same molecules tend to cycle through this process again and again for billions of years. There's something quietly comforting in that, if you let yourself sit with it. The water you drink today has likely, in some form, touched countless other lives before yours, flowed through ancient rivers, fallen as rain on forests that no longer exist, for been part of oceans long before there were any shores to call this earth's own. Life itself appeared on Earth remarkably early in its history, at least by cosmic standards, sometime within the planet's first billion years, back when Earth was still young, still settling into itself. The very first forms of life were nothing like the plants and animals we're familiar with today. Simple, single-celled organisms, quietly existing in ancient oceans, slowly, patiently finding ways to survive, to draw energy from their surroundings, to reproduce. For an enormously long stretch of time after that, life remained simple. Single cells, quietly persisting, slowly diversifying, but nothing resembling the complex, multicellular life we're used to seeing around us. It would take billions of years, most of Earth's entire history, so far, before life would begin to grow more complex, before the first simple multicellular organisms would appear, then eventually the first animals, the first plants, slowly, patiently building toward the vast diversity of life we see on Earth today. You, resting quietly right now, are the product of an unbroken chain of life stretching back nearly 4 billion years. every single one of your ancestors, going back through countless generations, through animals, through simpler organisms, 4, all the way back to those very first single-celled beings drifting in Earth's ancient oceans, managed to survive long enough to pass life onward to the next generation. Not a single link in that impossibly long chain was broken, not once, across nearly 4 billion years. It's a strange thing to consider, this quiet, unbroken thread connecting you to the very beginning of life on this planet, and through that, gently, to the stars that made the elements your body is built from, and further still, to that first impossibly small point where everything began. Along the way, that thread passed through so many gentle, gradual changes. Simple cells, slowly learning to work together, forming the first loose colonies, then the first true multicellular creatures. Life spreading outward from the oceans, finding its way, eventually, onto land, adapting slowly to air, to gravity felt without the cushioning support of water, to the long, dry stretches between rains. Plants learn to draw energy from sunlight in ways that filled the air with oxygen, slowly transforming the whole character of Earth's atmosphere over hundreds of millions of years, making it possible, eventually, for creatures that breathed the way you're breathing right now to exist at all. There were long stretches of near stillness in this story too. Periods where life seemed to simply persist, quietly, without dramatic change, for tens of millions of years at a stretch. And there were sudden, sharp turns as well, moments of enormous upheaval, when much of life on Earth was lost all at once through causes still gently debated and studied: asteroid impacts, vast volcanic upheavals, sudden shifts in climate. And yet, after each of these moments, however difficult, life found its way forward again, slowly, patiently, filling the spaces left behind with new forms, new attempts, new quiet variations on the same enduring theme. Mammals, the broad family that you belong to, emerged and diversified only after one of those larger upheavals cleared enough space for smaller, quieter creatures to slowly take root and grow. And within that family, after many more millions of years of gradual change, a particular branch slowly developed the ability to stand upright, to shape tools, to build fire, to eventually put careful thought into words, and words into stories. Stories like the one you're listening to right now. It's an almost impossibly long path when you lay it all out like this. And yet here you are at the very end of it, for now resting quietly, breathing slowly, carrying within you the patient, unbroken result of nearly 4 billion years of small, careful continuations. It might be worth spending a few quiet moments, too, on the instruments that let us see any of this at all. Because none of this story was handed to us all at once. It was gathered slowly, patiently over generations by people looking up at the same sky. You might glance at through a window tonight, wondering carefully what it was they were really seeing. For most of human history, the only tool available for looking at the sky was the human eye itself, unaided, catching only the brightest stars, the moon, the faint smudge of the Milky Way, stretching overhead on a clear, dark night. Then, a little over 400 years ago, simple telescopes began to change that, gathering more light than any eye alone ever could, revealing craters on the moons of other planets, faint smudges that turned out to be entire other galaxies, far beyond our own. Over the centuries that followed, telescopes grew larger, more precise, more sensitive, each new generation catching a little more light, seeing a little further, a little more clearly. Eventually, scientists found ways to lift telescopes above the Earth's atmosphere entirely, free from the gentle blur and shimmer that air causes even on the clearest nights, free to gather starlight completely undisturbed. One of the most well-known of these, launched several decades ago now, when spent years quietly gathering light from galaxies so distant that their light had been traveling toward us for billions of years. It captured, among many other things, a now famous image made by pointing at what looked like an empty, uninteresting patch of sky for many long hours, letting light gather slowly, patiently, the way a photograph exposes gradually in dim light what appeared for once all that patient waiting was done wasn't emptiness at all, but thousands of distant galaxies tucked quietly into a tiny sliver of sky no larger than a grain of sand held at arm's length. More recently, an even more sensitive telescope was launched, designed specifically to catch the faint, stretched infrared light of the very earliest galaxies, responsible for the ones that formed within the first few 100 million years after the beginning. It sits far from Earth now, quietly unfolded, patiently, patiently gathering light older than almost anything else we've ever directly observed. 4. Sending back images of galaxies so early and so distant that looking at them is, in a very real sense, like looking back through nearly the entire history of time itself. Every one of these instruments, from the earliest, simple telescope to the most advanced space observatory, shares something in common. They don't create the story we've been talking about tonight. They simply listen to it patiently, the way you might listen to a very old, very quiet voice, straining gently to catch every soft word. Somewhere, right now. One of these instruments may be quietly gathering a little more of that ancient light, adding one more small, careful piece to a story that's been slowly coming together for generations. It might be gentle, 2, 4, to think for a little while about where all of this is heading. Not tonight, not tomorrow, 4, not within any stretch of time that needs to worry you, but somewhere far off in the future. 4, so far off that the number itself stops feeling like a number at all and starts to feel more like a soft, open horizon. Our own sun, steady and warm as it is tonight, won't burn forever. In roughly 5 billion years, give or take 4, it will have used up most of the hydrogen fuel in its core. It will swell slowly into what's called a red giant, growing large enough to swallow the closest planets, warming and likely ending whatever remains of Earth by then. There's no need to carry any worry about that tonight. 5 billion years is longer than life has existed on Earth so far. It's a future so distant that it belongs to a different story entirely. 4, one that doesn't touch you, or this room, or this quiet night. After that, our sun will settle down, slowly, gently, into a small, dim, cooling ember called a white dwarf. 4, no longer producing new light of its own, just radiating away the last of its old warmth. Slowly, over trillions of years, far longer than the sun has even existed up to this point for other stars across the universe will follow their own versions of this same slow unwinding. Some ending far more dramatically in supernovae that scatter new elements into space, the prefrontal cortex responsible for seeding future generations of stars the way the very first stars once seeded the elements that became you. Others will fade quietly, gently, the way a candle slowly burns down to nothing, without any dramatic final flicker at all. Galaxies, too, will continue their slow drift. Most galaxies, pulled apart by that same mysterious dark energy we talked about earlier, will drift further and further from one another so far. Or eventually, that their light will never again be able to reach us, for fading beyond the horizon of what it's possible to observe. Some galaxies, ones close enough to be bound together by gravity, will instead slowly merge over billions of years, combining into larger, quieter systems. Our own Milky Way, in fact, is gently, slowly approaching a neighboring galaxy right now on a timescale so long, around 4 billion years, that it will unfold gradually, gently, more like two slow rivers merging than anything resembling a collision. Far, far beyond that, for in a future so distant, it's almost more comfortable to think of as a kind of story than an actual prediction. The universe may continue expanding, slowly cooling, slowly darkening, as stars use up their fuel one by one, and are never quite replaced by enough new ones to keep the lights burning the way they do tonight. Some very careful, very patient calculations suggest this process could stretch on for trillions upon trillions of years, so long that even the number 14 billion, which felt so enormous just a little while ago, tonight would look almost impossibly small in comparison. None of this needs to feel heavy. If anything, there's something almost soothing in it. The universe isn't in any hurry. It never has been. It took billions of years just to make the first atoms, billions more to make the first stars, billions more again to make you. It will very likely take just as long, if not far longer, to gently wind everything back down. There's a peacefulness in that kind of patience, in a story that never once feels rushed. From its very first moment to whatever quiet ending it might eventually have. You don't have to carry any of that distant future with you tonight either. It's simply part of the shape of the whole story, responsible for the same way knowing a river eventually reaches the sea doesn't make it any less pleasant to sit beside it for a while, right where you are, listening to it move slowly by. Let's slow down again here and breathe. You don't need to hold on to any of these numbers, any of these names. Population, stars, recombination, reionization, dark energy. None of it needs to stay with you past tonight. What matters more, for, if anything, does right now, is simply the shape of the story. A universe beginning, unimaginably small, unimaginably hot, slowly cooling, slowly gathering itself into atoms, into stars, into galaxies, into planets, into oceans, into life, into you. For it's a story that took nearly 14 billion years to arrive at this particular quiet moment, this room, this bed, this soft weight of tiredness settling gently over you. Scientists continue to study all of this, gathering clues from very old light, from the way galaxies move, from the faint patterns left behind in that ancient afterglow. New telescopes, more sensitive than ever before, or continue to peer further back into time than we've ever managed before, catching faint glimpses of galaxies that formed just a few 100 million years after the beginning. Galaxies so far away that their light has been traveling toward us for nearly the entire history of the universe. Each new observation adds another small, careful piece to this enormous puzzle, refining what we already understood, occasionally challenging it gently, prompting new questions, new careful investigations. Science, in its own patient way, is a bit like the universe itself, constantly expanding, constantly cooling into clearer, more settled understanding. Never quite finished, never entirely still. There's still plenty we don't know. What happened in that very first, unimaginably brief moment? Or right at the very edge of what our current theories can describe? What before could possibly mean, if it means anything at all? Why the universe is expanding the way it is, and what that means for its distant future. Whether the universe will continue expanding forever, growing colder and quieter with each passing billion years, or whether in some unimaginably distant future it might slow and stop and perhaps even begin to contract. Once again, these are gentle mysteries, the kind that don't need solving tonight. They've been sitting patiently for billions of years already. They can wait a little longer while you rest. For now, it might be enough to simply know this. For every atom in your body was once part of that first hot, for dense point. It traveled through the birth of stars, through supernovas, scattering light across the dark, through billions of years of drifting and gathering, just to become, for this brief moment, you. Breathing slowly, listening quietly. Part of a story that started long before there were ears to hear it, or eyes to see the light finally break free. Let's walk back through it once more, gently, slowly, for the way you might walk back through a house at night, checking that everything is quiet. Everything is where it should be before finally settling into bed. It began with a point smaller than anything, with no space around it and no time passing through it. Then, faster than anything else in this whole long story, that point began to stretch, expanding in a single, brief, extraordinary burst. From that burst came a hot, restless sea of the smallest possible particles, quarks, and gluons, too energetic yet to settle into anything solid. Slowly, as the universe cooled, they gathered into the first protons and neutrons. A tiny imbalance between matter and its shadow, antimatter, left behind just enough material for something to eventually exist at all. 4. In the first 20 minutes, the simplest elements formed. Hydrogen and helium mostly, waiting patiently in a hot, glowing fog too dense for light to travel through freely. Then, after roughly 380,000 years, that fog finally cleared. Atoms became whole. Light was set free. 4. And it's still traveling now, filling the whole sky with its faint, ancient hum for hundreds of millions of years. After that, the universe rested quietly in the dark. 4. Gathering itself slowly under the patient pull of gravity, until finally the first stars began to shine. Those stars lived, and many of them died, scattering the heavier elements they'd built across space. Elements that would one day become oceans and bones. 4. And the quiet breath moving in and out of your chest right now. Galaxies formed. Our own sun formed 9 billion years into this story, and around it, our own small, quiet planet. Water gathered. Life appeared, and slowly, patiently, across nearly 4 billion unbroken years, it grew and changed and eventually became curious enough to build telescopes and equations and stories like this one, all in an effort to understand where it had come from. And now, after all of that, after nearly 14 billion years of stretching, cooling, gathering, and quietly settling, here you are, at the very end of the story, for tonight, resting, breathing slowly, part of everything that came before you, and, in some small, quiet way, part of everything that continues to unfold after you drift off to sleep. Think, if you like, just once more about that ancient light we talked about earlier. Still traveling even now, filling every corner of the sky with its faint, steady hum. It's been traveling for nearly 14 billion years, patiently, quietly, never once stopping, never once needing anything from anyone. It doesn't rush. It doesn't hurry to arrive anywhere. It simply moves steadily at its own gentle pace, the same pace it's always moved at. There's something worth borrowing from that, maybe, tonight. You don't need to rush anywhere, either. You don't need to arrive at sleep the way you might rush to catch a train, checking the time, feeling the pressure of some invisible deadline. Sleep, like that ancient light, will arrive in its own time, gently, quietly, without needing to be forced. The universe took its time getting here, for nearly 14 billion years, patiently unfolding one slow step after another. There's no reason you can't take your time too. Let your breathing slow, the way the early universe slowly cooled, patiently, gradually, without any rush. Let your thoughts drift, loose and unhurried, the way those first clouds of gas drifted together over millions of quiet years. Gently gathering, gently settling. There's nowhere else you need to be right now. Nothing left to figure out tonight. No question that needs answering before you're allowed to rest. Somewhere above you, that ancient light is still traveling, softly, steadily, filling the sky in every direction, the way it has for nearly 14 billion years, the way it will likely continue to for a very long time yet. And somewhere within you, quietly, steadily, are atoms that were forged inside stars that burned out long, long ago, atoms that traveled an impossibly long journey just to rest here. Now, in this body, in this room, in this particular quiet moment, you are, in the gentlest and truest sense, a very small, very warm piece of a very old universe. Finally, after 14 billion years, getting some rest. Just the soft hum of that ancient light, still traveling, and you resting quietly beneath it. Let your eyes stay closed now, if they aren't already. There's nothing more to follow, nothing more to track. Just the slow, steady rhythm of your own breath, in and out, in and out. Patient, the way the universe itself has always been patient. If your mind wanders back to anything we talked about tonight, that's all right too. Let it wander gently, without effort, the way light drifts quietly across billions of years of empty space, never forcing its way anywhere, simply moving, simply existing, simply arriving, eventually wherever it's meant to be. You don't need to hold on to the story any longer now. You can let it go, the way the universe once let go of that trapped ancient light, setting it free to travel wherever it wished. Let yourself be set free too, gently, from any thought that feels heavy or holds on too tightly. There's only this quiet room, this soft weight of tiredness, this slow, unhurried breathing. Rest now, if it helps. Let your attention settle gently into your body for these last few minutes. The way matter once settled gently into the first quiet, clumps of gas slowly, without any effort, simply following its own natural pull. Notice the weight of your head resting on the pillow, heavy and still, the way the first solid ground on Earth finally settled after millions of years of slowly cooling. Let your shoulders soften. Let them sink a little further down, releasing whatever they've been quietly holding onto today. There's nowhere for them to hold anything up right now. Nothing left to carry. Let that same soft heaviness move down through your arms, gently, unhurried, the way starlight drifts slowly across empty space, never rushing, never needing to arrive anywhere sooner than it naturally will. Let it settle into your hands, your fingers, however they happen to be resting right now. Notice your chest rising and falling slowly, evenly. The same slow rhythm the universe itself has followed for billions of years. Expansion, and then a gentle, patient settling. There's nothing to change about your breathing right now. Just notice it. The way you might notice a very old, very familiar song playing quietly in another room. Let that heaviness continue down through your stomach, your hips, softening further with every slow breath. Down through your legs, your knees, your feet, all the way to the very ends of you. The way that first burst of matter eventually spread outward to the very edges of everything that exists. And now, just for these last few minutes, there's nothing left to do at all. No more story to follow. No more thoughts that need finishing. Just this quiet room, this soft, heavy stillness, this slow, patient breathing. The universe has been patient for nearly 14 billion years. It can certainly wait a little longer while you drift off slowly, gently, the way everything in this long, quiet story has always unfolded. One soft, unhurried moment at a time. Sleep well.